Let's see the first example in Bernoulli's equation and including the head losses. So we have one example here. We have two large reservoirs, upper and lower reservoirs, and there are like a series of pipelines connecting between these two reservoirs. We have the entrance of the pipeline from connected to the upper reservoir, which is sharp. So we have some sort of like a minor head loss in here. And the pipelines at the midpoints, the diameter changes and increasing double suddenly. And also at the exit point of the second pipeline to the lower reservoir, we have the exit point that we have a sudden exit and the velocity head is lost. So the exit from the second pipe to the lower reservoir is also sudden, so that the velocity is lost in that point. So the question here is to sketch the total head line, THL, and HGL, or hydraulic rate line. So you can already see this kind of like the THL and HGL has already been plotted or drawn here, but I'm just going to just explain to you why this happens, because this sort of things is something that you might need to just be able to draw on your own. So let's look at this from the beginning. So at the beginning, we can see here, there's no velocity. So the total headline, THL, is exactly at the water surface level. So once the water taking to the pipe, we have the first drop of the minor head loss happens. Because of that, we have like a drop of the head loss, number one, and the THL, so the total energy headline. So you're just going to start from this point. As you know, the HGL is lower than the THL by the velocity head. So if you're just going to take away the velocity here, this is the velocity. The difference between THL and HGL is the velocity. We can have the HGL as well. So the HGL is something that we can see in the any kind of like a piezometric pressure, or any standing pipe. It shows the HGL. So it's the pressure that we can feel. So, and once we're just going to the flow running through the pipe, we will lose the energy head loss due to the friction head loss, friction of the sides. So we have like a decreasing gradient, both with the same level, because we just lose energy head loss with the same rate. So it's just decreasing up to the point or down to the points of the changing of the diameter. And at this point, changing the diameter, what would happen? We have another like a minor head loss because of the increasing the size, the diameter size. So we can have, so the number two, by the way, is like the friction head loss because of the pipe number one. So we have another like the head loss because of the expansion of the pipe. So number three is like the minor head loss due to the expansion of the pipe. So we can just reduce this one. But HGL, there is something that happens for HGL. So you know, this is one like the velocity here. Once it just goes, the same flow goes to like a larger pipe, the velocity decreased based on the continuity equation. Because the velocity decreased, to the velocity head reduce. So the velocity head, you know, if you remember, it was this amount. So it can reduce. And so, for example, we have from here, because this is like we have a drop minor head loss because of here. So this is the total headline after deduction of the expansion here. But here we have the velocity has got this amount of share. It's reduced by this amount or reduced to this amount. And the rest of that is occupied by the HGL. So the HGL just occupied that one. So the pressure head will take up the rest of the energy headline and the pressure. So we can have like the increase in the pressure head and reduce in the velocity head. So we're just gonna have this one. And again, we can have another type of like a friction head loss due to the pipe two, which is shown by number four. This kind of like a graduation decreasing trend or decreasing like the gradients. So you can see here total both THL and HGL decreasing. Just bear in mind there is something, the gradients of this line of these two dashed lines compared to this line is a little bit milder. This one is a little bit steeper. Why? So the reason is that because the diameter is increasing. So the diameter, if we remember, the diameter has got an indirect relationship with the friction head loss. And if the diameter increase, so we just we just lose the friction head loss smaller with a smaller rate. Okay, and that's the reason that this gradient, decreasing gradient, is milder, and then this one is steeper because the diameter was really small in here compared to this one. So we can have with a like a little bit smaller or milder gradient decreasing trend. So you're just going to get to this point. And exactly at this point, as it mentioned here, we have an exit minor head loss. The exit minor head loss happens here. And it's exactly, we lose by the velocity head here. So the velocity head, we lose that one. And hydraulic grade lines exactly get to the water surface here. So that number 5 is like the exit minor head loss. So this is example 1. So the drawing the or sketching the total headline or hydraulic grade line between the two reservoir.